talk about end behavior of polynomials and why the graph of a polynomial, why the end behavior of the graph of a polynomial is determined by the highest power of the polynomial and its leading coefficient. Rather, the sign of its leading coefficient. So I put together this little Excel spreadsheet that might show it a little bit better. This was the polynomial that I'm working with. X to the fifth minus 2x to the fourth plus 3x to the third minus 4x squared plus x plus 3. This will be true of any polynomial though. So this is a spreadsheet I put together with that particular polynomial. I have evaluated this polynomial for this number right here. I'll make that yellow so everybody can see it better. And as you can see, when I put 0 in for x, all of my terms that have any x in it are 0. My polynomial is evaluated to be equal to 3 because that's my constant at the end. And my constant here makes up 100% of the value of the evaluated value of this polynomial. Well, let's change this. Let's change it to 1. So I'm starting to move along my x-axis towards the positive, and I start to get some numbers here. And I can still see, well, you know, my x to the fifth is 1. Well, first of all, it evaluates for 2. And my x to the fifth accounts for 50% of that. My minus 2x to the fourth takes away 100% of it. My 3x to the third represents 150% of it, and so on. I'm going to go up a little bit higher. I'll go to 2. Well, now, x to the fifth represents 246% of my final solution of 13. That's because 2 to the fifth is 32. Exponents, as you recall, are very powerful. So when I take 2, but I raise it to the fifth power, that's pretty big. Now over here, I'm raising it to the fourth power, but I'm multiplying it by 2 again. So that's why my 32 here, and I have a negative 32 here, they kind of cancel each other out. Well, let's go over here. Let's try 3. We're going to make x a little bit bigger. Well, now it's 184%, my x to the fifth of my end value. But one thing that I begin to notice is that my lower value terms, my constant, that's x to the 0th. Oops, let's make this bigger here. My x to the 0th. Let's make it a little bit smaller too, so we can get all these numbers in. Is only 2%, and even my power of x to the 1 is 2%, and my x squared is negative 27%. That's still significant, negative 27%. Well, let's go up to 4. I'm evaluating this for 4 now. Well, at 4, the total value was 647, but you can see out of 647, my power of x to the 0th, my constant, is negligible. And my power of x to the first power is also negligible. What happens when I move it up to 5? Well, now even my power of x squared is becoming really kind of negligible, because x to the fifth is, as an exponent, is so much more powerful than x squared, even though I have a coefficient here of 4. Let's go to 6. Well, it's even less. 7. Let's take it up to 20. Well, at 20, the only 2 terms of my polynomial that are really having any effect at all are my x to the fourth and my x to the fifth. And my x to the fifth is having a much larger impact than my x to the fourth. Now, that's only from 0 to 20. We're not even talking about infinity. Let's give it a big number. Let's give it a number like, well, let's give it 100, which really isn't even that big of a number itself. Well, at 100, my x to the fifth represents almost 100% of my value of my value of the function. My x to the fourth is a really negligible part. If I take it up to 1,000, which again isn't that big number in the overall scheme of things. Well, if I take it up to 1,000 already, x to the fourth, x to the third, x to the second, x to the first, x to the 0th, they are all totally insignificant. And the only thing that is having any really serious impact on the evaluation on my function, the y value, is my x to the fifth. That is my highest power.